happy to be here. Thank Daniel and Kamailio for having me here to present some of my experiences as a long-time user of Kamailio. Here I'm sharing my screen.
Okay.
Can you see that?
Yeah, I can see.
Okay. Right, okay. So the title of this presentation is about high availability for Kamailio and RTPEngine. I'm Yufei Tao. A quick introduction for myself. I got my PhD from York University and in analog filter design, and spent 4 years doing postdoc in binaural 3D sound. And ever since, I have been working in industry, different companies, and I hold 2 patents in telephony signal processing. Now I work with Syntec and my own consultancy company, Tao Communications. Right, so Kamailio and RTPEngine are very popular VoIP software platforms for SIP signaling and media. There are many use cases for them. They are very robust proxies, and people use them for relaying across different network interfaces, NAT traversal, and use them as gateways for some conversions, like SIP transport protocols. You can convert between UDP, TCP, TLS, that kind of thing, and codec transcoding with RTPEngine. And you can do encryption, decryption of SIP and media. Here is one simple so-called SBC setup. With SBC, traditionally, we refer to the B2B UA. But many times people want SBCs. Basically, they need something that can be fulfilled by proxies as well. For example, here we have a Kamailio and RTPEngine working as a so-called SBC. It sits across 2 network interfaces, external and internal, for example. And they are doing a few things in here. NAT traversal. So SIP and RTP can be relayed by the SBC for the devices behind firewalls. And also they can relay your calls across different network interfaces for network segregation purposes. And also Kamailio can do your routing logic and maybe load balancing dispatching for other application servers in the internal network. So when we talk about high availability, we are actually talking about 2 things. The first thing is you have to make your server itself as reliable as possible. Well, if you have implemented some VoIP systems, or if you are a programmer, you probably find the happy path is the easiest. You spend maybe 20% of your time to make something that works most of the time. But it may crash down to its knees or have some troubles after some time. But in these cases, probably you will need to consider edge cases. These are taking more effort to handle. You have to consider expect the unexpected, and like unsuccessful calls, the call flows which are not quite done according to the flow, RC flows, or missing call terminations. In that cases, you might have a memory leak in your script. So if you don't release the memory in the hash table, for example, quickly enough, they might build up, for one example. And also in different deployments, you might find different call patterns. They may trigger different problems than other deployments. So after the deployment, you probably need to monitor and take a look at the real traffic, what they look like, and then retest using those real traffic, so that it helps you find the problems you might have missed. So basically, Happy Path is quite easy, and then making it run all the time takes a lot of time. When you have a reliable server, sometimes you can still get hit by problems from different directions, all sorts of failures, and or maybe you could you want to bring your server down for maintenance or something. In that kind of situation, a backup server will be very helpful. So you still have your service running without being disturbed. Okay, a little bit more about the first point, having a reliable server. In my experiences, I find it very important to keep the things as simple as possible. So stick to the KISS principle, keep it simple. Something else, give the next word. So it helps you to make the design and implementation easy, and helps you in the long run, more importantly, debugging, maintain, and upgrade. There are a lot of Kamailio modules providing a lot of functionalities to help you create your services. But I have seen some people having a misunderstanding. For example, they would assume you have to use the dialog module if you ever process the connected calls, but it's not necessary. And the ready-made database tables are there to help you if you find your requirements fulfilled very well with those pre-existing ones. But if you are only doing some simple proxies, then they can be an overkill for your needs. In that case, you can try your best to keep the things simple. Well, for a simple proxy, the only things you need to do may be just to get the SIP headers right and send them to the right place and on the right socket. If you have some pieces of information you want to record, save for the call, maybe for later processes, you can create some entries in your hash table. The htable module is very useful. Here is an example where you could, for example, save some from and to tags and a call direction, so that in the later stage you could play media to a specific call leg. Here's an example for setting up Kamailio for failover. Here we have a simple master and slave node. Node A is by default configured as master, node B is slave. In a normal situation, we have a virtual IP allocated to node A, and the calls flow through node A and handled here. And then when node A wants to record some information in the hash table, the DMQ module takes care of the replication. So node B will have all the information from node A saved in his memory as well. When the failover happens, say your node A is gone, the virtual IP is migrated into node B, and node B becomes the new master. It's got all the information it needs to continue processing with the call and take new calls from there on as well. For the Failover Protocol, we have chosen Keep Alive D, which is a popular choice. You can find on the internet that many people are using this for the VoIP system. It's quite easy to set up, and it can monitor your network interface and as well as the application status as well. So it basically assigns the virtual IPs to the default master node, as you can define. And when the master node goes down, it moves the VIPs over to the slave node, so the slave can continue with your service without stopping it. And here we can see a example of the keepalive.conf for the master mode. You can define the state to be master by default, and you give it your virtual IP, and also you provide it with some check script where you can define, you can put whatever your monitoring polling scripts in here. So this one is run on a given interval, and when the check script fails, the failover will be triggered. And this notify script will be run when your master-slave status changes. For the applications, for example, Kamailio, it needs to listen on the virtual IPs. In order to do that, you have to set a sysctl conf file, a non-local binding. Otherwise, it can't start up. A few notes about the Kamailio routing configuration files. Usually would like to use it in stateful mode using the transaction module, because it automatically handles the transaction layer tasks. And also you might have some other modules that depend on the TM module. There is no support for replication of the transactions between the nodes, but still there are possible ways you can do to handle most of the failover scenarios. So most often, if you have a bunch of calls on your server, when failover happens, it's going to hit some established calls because they have a quite long duration usually, and it's more likely to be hit when your failover happens. In such cases, the co-establishment transaction has already finished on node A, and the failover happens outside the transaction. So in that case, it's quite easy to handle. On node A, you have invite, OK, and ACK completed already. And then in processing the initial invite, you probably set up the routing for it, find the correct destination according to your routing logic. And if you are relaying across different network interfaces, you probably need to find the correct socket to send it, force the socket. And then you do the record route so that in dialog messages will be handled by loose route without automatically by Kamailio. So when failover happens on node B, all these in-dialog transactions can be handled automatically using loose route. So this one is probably the most worrying situation because you have live calls. You don't want them to be affected by the failover, but it is the easiest to handle as well. You just use the conventional default configuration that should work. And we have now some situations we need to consider where the failover happens inside the transactions. Because the transactions cannot be replicated across to the slave node. So we have a think what will trigger, what will be triggered by this failover inside the transactions. One situation which might happen quite likely is that the OK to the invite goes to the slave node B. Because it might take many seconds for the user to pick up the phone to answer it. The probability here of getting hit by the failover is kind of not too low, maybe. So in this situation, node A will handle the invite and the 100-something responses. It will set up the routing for initial invite. It will find that it will do the routing logic, find the destination. Optionally, you might force the socket for different network interfaces, and it does the record route. And then node B will have to, after the failover, node B will have to handle the response and the ACK. The response responses can be handled by the via headers by Kamailio. However, if you have more than one network interfaces, then you might have you will have to force the socket for this response. And then we have the ACK after the response, which could be an OK. And then if that's the case, then the ACK will have the root headers. It will be handled automatically by Kamailio using the loose root. And if the ACK is for error response, it will be a bit different from this. So we'll cover that a bit later. And another situation where failover could happen inside the transaction is the cancel. So in this case, invite and 100 something responses hit node A, and then the failover happens, and then the node B will have to handle cancel OK transaction and the other half of the invite transaction. So in this case, for when the cancel comes into node B, which has no idea about the invite transaction, it will fail to find the invite transaction. There are two choices we can handle that situation. The first of all is we could use the same way for handling the initial invite to handle the cancel routing, because according to the RFC, the cancel message looks pretty much the same as invite. So if you have a pretty simple routing, so anything coming from one IP will be sent to the other IP, you can do just a routing lookup according the same way as the invite. Or another way is when you process the invite, you might find the routing and then save the destination. So you can use the save destination to relay the cancel. So an example of the script in here, without the failover, cancel is relayed only when the relevant invite transaction is found. But here, even if it's not found, we do some kind of routing, the either of the two ways usually, and then we relay it on after all. Right. This one is the ACK for error responses, which we didn't talk about 2 slides ago-ish. So usually you would see in the example configuration file something like here. So the ACK, if you find a transaction for it, relay it, otherwise we don't. And with a failover in mind, we might do something like this. If you don't find a transaction, we'll do some kind of routing, find the destination, or use the saved one, and then we relay it off. There is some difference between the relayed ACK and the usual ACK, hop by hop ACK, which is in the relayed one, obviously we have more than one wire headers. The top one being your proxies, and then the one next to it, after it, will be your previous hop. But usually, if we don't do the failover, you probably just see one via. And here we have a summary for Kamailio failover. So usually you need to save some information for the call, and you can do that in a hash table. And you can use DMQ for the replication. So the slave has all the information it needs when the failover happens. So for a simple Kamailio proxy, it is possible to handle most of the failover cases. But when you think about it from a user point of view, the most important one we worry about is the established calls and successful call attempts. For example, the OK coming onto the node B. And these two are easiest to handle in the scripting point of view. And we have to bear in mind that it takes usually 3 or 4 seconds-ish for the virtual IPs to migrate with keep alive D. Okay, there's something we need to talk about RTPEngine failover. We can have a redundancy standby RTPEngine server to avoid loss of media. Because after the call is connected, when there's a few second gap, it's more noticeable than for signaling. You can hear silence. But for scripting, it's easier to handle because you don't have to worry about the different stages where the failover happens compared to inside a transaction or outside. There is a way people are doing this for RTPEngine failover, which is based on Redis key space notifications. I found these two references extremely useful, and it's quite easy to set up when you have a look at these references. Okay, so here is a simple setup for RTPEngine failover. In fact, with this method, you could have multiple RTPEngine nodes doing the replication. But here is a very simple scenario we are illustrating. We still have a master and slave set up. And for node A, which is the default master, it writes to DB1 of Redis database, and it subscribes to DB2. And for node B, it's the other way around. In a normal situation, the virtual IP is allocated to node A, and the calls are relayed by node A, and the information of the live calls are written into DB1. And the notifications for those events will be sent to node B because it subscribes to the DB2. And so slave node B will have all the information about all the live calls. When the failover happens, node A is gone. It takes a few seconds for the VIPs to migrate to node B, and then node B will continue relaying the media. And if there are new calls establishing scenes on the node B, it will write all the information into database DB2, and the notifications will be sent to A. And if A is brought up again, it will get ready to be a new slave. Right, okay, so here's a summary. It is possible to achieve reasonable high availability setup using Kamailio and RTPEngine. There are different ways, of course, to combine the Kamailio and the RTPEngine. You could, for example, put them on the same box, share the same VIPs, and then failover at the same time. Or you could separate them out so they do failover independent of each other. And there are other ways, of course, to achieve high availability with these proxies. So if you have other idea, I'll be really happy to discuss. Right. Okay, that's it from me. Time-wise, is kind of okay. And I need to thank Kamailio and the team for providing such a robust software for free as well. So it provides many people with job opportunities and making money, and it's really we are really grateful for that. Yeah, that's me. Any questions?
Thank you, Yufei, for another interesting presentation. For the audience here, check the recording on Kamailio World YouTube channel, because Yufei had another very useful presentation at the previous edition of Kamailio World. So she does have an extensive experience with Kamailio and other VoIP applications. I saw a couple of questions on the channel. One of them was from Ole, whether you know if for RTPEngine it's working failover for SRTP. Not sure.
Yes, it does work. I tried SDP, SDS, SRTP. It does work. And the DTLS, not yet. I think there's a small problem that can be fixed.
Okay. Thank you. Then, Tori, can you clarify how you relate 200OK out of transaction?
The responses are automatically handled by Kamailio using the via header. So if you only have one network interface, then you don't have to do anything special. But if you relay the calls across two different network interfaces, then you need to force the socket for the OK, and then everything else just happens automatically.
Yeah, that's true. And I want to add here, for those that are not aware, now you can add some tokens in the via generated by Kamailio. I added that feature targeting any class deployments, but you can use to store some cookies like interface name for which to use, which one to use for sending the reply. It's very convenient, especially with the last release. You can associate a name to a listen. So you have like listen, socket, advertise, public IP. If you need it name and a unique name, that then makes it easier to send for send sockets, sorry, and other functions work also with it, like record routing and so on. Makes it easier to deal with this situation when you have multiple network interfaces. Any other question for okay. I'm not sure if I saw anything else, so probably this is it. I don't see any other question. No question on the YouTube channel. Thank you again, Yufei, for your time preparing and being part of our celebration event. And I have to thank also for the patches you sent to Kamailio, especially helping with Kenya exports. So thank you for all your work with Kamailio and contribution on many planes, community, presentation, and code. And looking forward to see you at the event online, or maybe better on site in the near future.